My name's Jennifer Woods. I marked this Mathematics Standard 1 paper last year, and I'm going to give you some feedback on questions 18, 19, 22, 24, 25, 26 and 28. So with question 18, it was substituting into a speed formula, and U and V were the starting and finishing speeds. And students had to evaluate D after substitution. Some of the things that they did well were they were actually able to select the correct values for U and V, and they knew to square them, and they could do that successfully. Some of the concerns were that students struggled to substitute U and V in the correct place in the formula. So they switched U and V because U and V in the question is from U to V and from 70 to 40, but in the formula it was V and then U. So it was a lot of reversal that we saw. And very few students were able to solve for D following the substitution, which really looks at order of operations. So common errors were doing 1600 minus 100 rather than doing the subtraction of 16 or whatever other order of operations or equation solvings that they needed to do. So we want to encourage students to tackle more worded questions where they need to select the data and solve more equations following substitution to find a value which is not already the subject. So that rearrangement following substitution is what they need to work on. Question 19. This was each year the number of fish in a pond is 3 times that of the year before, and they had to fill in the table with the missing data, and they did that quite well. Some areas for development with students who didn't manage to be able to do that is to work on interpreting written mathematics, such as 3 times that of the year before, because that was the stumbling block for some students. They then had to plot those points from their table, whatever they got, on the grid, and mostly they were able to do that. Some of them were incredibly inaccurate, so that showed that they didn't understand the gradations or the scale of the axes. So we would like them to do more plotting of points on unfamiliar scales or unfamiliar coordinate axes. I think that would be really helpful. In part C, they had to say which model was more suitable for the data set, linear or exponential, and explain their answer. And fortunately, many students were able to state that the model was exponential, given the choice between linear and exponential. Some of the students tried to adjust their plot to make it look like a straight line, and then say it was a straight line. And they then contradicted themselves in their explanation. So, so some of them knew that it was exponential, but found it very difficult to explain why. So students are encouraged to be able to identify the types of graphs given their shape, so labelling the types of graphs they've got, and to be able to articulate the actual behaviour of a graph. So something like with exponential, it wasn't enough for them to say that it goes up each year, because a straight line graph goes up each year. They needed to say that it goes up by a bigger amount or a larger amount each year, something of that nature. Question 22. This was our correlation question. So describe the strength and direction of the linear association observed in this data set. The cue for the students there was strength and direction. And we really just wanted to see that they could say it's a strong association and a negative direction. Many students weren't familiar with the required terminology. And so we're encouraging them to learn the precise statistical terms. Students shot themselves in the foot a little bit when they would say things like moderately strong, relatively strong. They need to be quite precise in the language that they're using. calculating the range of the test scores and drawing a line of best fit. Some students were able to find the range without too much trouble, and most students knew that the line of best fit was a straight line which needed to pass through some or all of the points in the middle of that grouping, not outside that grouping. So some of the errors were that students really did struggle to find the range of the scores, which were on the graph rather than a list of numbers. We don't often ask students to find the range of a set of numbers if it's not in just a straight list. So that was unfamiliar for the students. And a common response was to report that the range was 80 to 100 rather than giving a single value. So we want them to apply statistical calculations to data sets which are presented in various forms, and particularly to use a ruler when drawing a line of best fit. It makes it very hard to judge whether something's a straight line if they're not using a ruler. So we're looking for a little bit more precision. Now, I know you might say, oh, but it's just standard one, you know, these kids are struggling anyway. However, it's important that we encourage them to get the basics right, and having a ruler is really important. Now, in this section, this was basically interpolation and extrapolation, D and E. So we had to use the line of best fit to estimate Meg's score. They were able, in general, to locate the value for 5 missed lessons on their constructed graph. Students gave a range of values or read off the scale incorrectly. So instead of giving one answer, they would give this, this, or this, or they read off, just couldn't read the graph correctly. And what we really need them to, what was important here is if that they didn't complete their line of best fit, then they weren't able to access the mark here for D, because they're asked to use the line of best fit. So if they didn't have one, they couldn't use it. So it's important that they complete all parts of the paper to the best of their ability. In E, John didn't sit the test and he missed 16 lessons. And very few students were able to express the fault in using extrapolation in this case, it being that the value of 16 is well beyond the data set given and would produce an unreasonable result, being a negative. One of the things that we noticed also is that students need to be encouraged to use mathematical terms and vocab rather than hypothesize in their responses. So for John missing 16 lessons, there was a lot of ethical statements about him being allowed to be estimated for having missed so much work. And they need to use mathematics in their reasoning. Okay, question 24. This was the cinema statistics question. And the students were given a list of numbers and they were told the mean is 47.1 and asked how many of the 10 people were aged between the mean and median. Now, the students were able to arrange scores in ascending order and find the mean of the middle two scores to try and find the median. So there were good attempts at finding the median in this question. Some of the errors that were encountered were that they didn't actually put the scores in order and just found the median of the two middle scores, 55 and 68, which led to errors. And a range of errors that led to us to believe that they didn't understand what the question was asking. So some students would find the mean of the scores that they were given again, or add 47.1 or add in 10 or any combination of those things. So this question was a little bit interesting because they actually didn't need to calculate the median to do this. If they just put the questions in order and compared 47.1, they would have seen that the median was halfway. 47 was the next score along, so they could have just selected it. So it was an interesting question. It really tapped into whether they understood what was going on. So we're encouraging students to perform more statistical calculations on unfamiliar data sets and contexts, and to read questions carefully and check they've answered what the questions actually asked. The second part of this question was proposing a different data set to compare to the data set on Saturday, saying that all 10 people that attended were 70. And then the students were asked about the standard deviation, whether it would be larger or smaller. And students were able to link part A and B, so they knew that it was all part of the same question. But the errors were that they would confuse the Wednesday and Saturday data sets, and that very few students were able to link the less spread of ages, or the ages being all 70 as a lower spread with lower standard deviation. We're encouraging students to work on more worded questions where they highlight keywords and data. So one of the strategies that we really need to build in is that idea of the highlighter, getting those keywords, key data and key information in the question, and really shining a light on those so that kids have got a step towards starting the question. We also need to encourage them to develop a greater conceptual understanding of the statistical calculations of centre and spread in unfamiliar contexts, because this is a theme that I saw in these questions that the team marked. That they were going through a process, but you weren't always sure that they knew why they were doing what they were doing, and that's where they come unstuck. One of the things with this, that students thought that the standard deviation would be much higher because the ages of the people were all 70. So they were confusing mean there with standard deviation. The question also says, explain your answer without performing any calculations. And I think we could do more work in our classes on those sorts of questions. Question 25. This was an interesting question to mark again, because it was quite a number of marks, 3 marks, unscaffolded, which is something that we're aware happens. And there's a lot of reading for the kids to do, and only 1 line for them to answer. So I think that's something we could work on with our kids, that yes, it was 3 marks, but there was only 1 line in the answer. So if you're looking at doing lots and lots of calculations, you might be on the wrong track with this one. So Tom had to do 2 different investment options, a simple interest and a compound. The compound interest option was already graphed for him, and the students had to sketch the straight line that represented the option A for simple interest, and then do a comparison of the investment after 8 years. Now, some students were able to sketch the straight line and find the correct difference either from a graph, from their graph, or from calculations. And a lot of students did do additional calculations rather than just very simply plotting the straight line. Students misread option A as compound interest, which made the graph and subsequent difference very difficult. If you were looking at doing a compound version of option A, it's very hard to graph separately from option B. And we saw that a lot of students did manual calculations for that. So candidates are encouraged to read questions carefully and follow instructions and use a ruler for straight lines. There's that ruler again. Because up the top it says, by first drawing on the grid above the graph of the future values. And we did have a number of responses where a graph had not been drawn at all. And we want them to know the difference between simple and compound interest graphs. i.e. that the simple interest is a straight line and compound interest is your curve. Question 26. This I thought was well done by the students. Most students were able to complete the tables with all the correct values, and that they knew that the sample space was 36. That was quite pleasing. Students frequently misread the instructions for completing the table. They didn't notice the word difference, and they did their traditional add the two values, even though that didn't match with what was there. A significant number of students found P0 only. In other words, they actually had to find, well, they could have done this a number of ways, but a number of students found the probability for getting a zero, score of 0, rather than not, okay? So they're encouraged to read the question carefully. That's a theme, and it's a theme every year from the marker feedback, I'm sure, and check that answered what has actually been asked. And the last one, it was really challenging for these students, unscaffolded 4 marks. And it was pleasing that some students were able to calculate BC in the first triangle, given that the area of that triangle was 20 square centimetres. Of course, there were errors in students who tried to do that where they divided by 2 instead of multiplying, or multiplied by 8 instead of dividing, or whatever it was error that they made. But many students were able to link area for ABC in an attempt to find BC side. Others demonstrated some skills with Pythagoras theorem and used ratio to find a side length, or tried to apply trigonometry. So lots of good attempts. And a few students were able to actually complete the question and achieve the correct answer for side DF. Unfortunately, some students didn't know how to start the question at all and found it challenging to work the area formula to find the side. And with this question, if you didn't get BC, there was actually no way that you could progress for 4 marks. So they really needed to get that first cab off the rank. Now, students who couldn't get BC, they often made up a value and then progressed from there. So our encouragement to students is to attempt more unscaffolded questions requiring multiple processes. And I will say there are multiple concepts and topic areas. This one required, you could have used Pythagoras theorem with similarity or ratio. You could have used trigonometry with ratio. There's a whole lot of different strategies you could have used with this one.